learning JavaScript libraries and frameworks can feel overwhelming. So many options, so much complexity, and the jargon, it's enough to make anyone feel stuck. But what if there was one best bet? A tool that not only simplifies web development, but opens doors to mobile development too. That's React.js. Hi there, and welcome to a course where I'll take you from a React.js beginner to confident developer, without endless theory or aimless code copying. This is about building something real while truly understanding it. Starting from what React.js is and why you should learn it, to how it works under the hood. React.js fundamentals, JSX, core syntax, hooks, and React 19 features. And finally, we'll build a modern movie app with a top trends feature that showcases the hottest movies people search for. By the end of this crash course, you won't just know React.js. You'll have created something you can showcase. But that's not all. For those ready to dive even deeper, I've put together a free guide and a comprehensive React.js course designed to take you from zero to production ready. Whether it's learning state management, testing, or advanced patterns, this course will help you build and deploy apps like a pro. You can find all the links in the description below. But for now, let's dive into the video. Together, we'll build an awesome app with a break the trends feature using AppWrite to handle backend tasks seamlessly. Let's get started. React.js is a game changer, a JavaScript library created by Facebook that powers some of the world's most dynamic user interfaces. It's maintained by a strong open source community, constantly innovating with new features like server components, which simplify your backend workflow by running React on the server. And it might seem like React is borrowing PHP's homework for building server-driven websites, but it's more like React speaking at PHP's notes, modernizing them so you spend less time reinventing the basics and more time building amazing apps. Of course, React isn't alone. Frameworks like Vue.js, Svelte, Astro, and Angular are also making waves. But when it comes to popularity, React dominates. Just look at the numbers. 42% of the developers on the Stack Overflow Developer Survey chose React, and it is the biggest programming survey in the world, featuring all of the programming technologies. So for the React to be that high, which gives that number a lot of weight. React has also topped the State of JS survey for 6 consecutive years as the JavaScript library of choice. And with a good reason. React is the backbone of key stacks like Mern and Pern, extends to mobile development with React Native, and integrates seamlessly with modern frameworks like Next.js for full stack development. In short, learn React and you'll have the tools to build apps for web, mobile, and beyond. It's your ticket to becoming the Swiss Army knife of developers. Now, let me show you what makes React so powerful with a project that I made specifically for my upcoming React.js Pro course to help you visually understand React patterns in practice. And it's built entirely in React. This app showcases React's smooth instant updates. You won't see a single page reload or a loading spinner, even when browsing different sections. Everything happens dynamically on one page. How? Well, React uses JavaScript and the virtual DOM to make it all possible. The virtual DOM is like a simplified map of your web page, a JavaScript object that mirrors the real DOM. Here's why it's revolutionary. When something changes, React creates a new virtual DOM element. It then compares it to the old one to pinpoint the difference, and only the changed part of the real DOM is updated, making React blazingly fast. Think of it as updating a single tile in a mosaic instead of repainting the entire wall. And React doesn't demand much, just a solid understanding of JavaScript. So if you're unsure about concepts like ES6 plus syntax, pause this video right now and go check out my complete JavaScript mastery course. It'll make sure that you have all of the necessary prerequisite knowledge to be able to get the most out of this course. And for a more focused approach, or if you want to have a reference guide always available, download my free Ultimate React.js guide, linked in the description, packed with prerequisites, core concepts, and project ideas to get you started. And now that you understand why React is so popular, let me teach you how to write React code and introduce you to its syntax. We'll start with the basics and slowly move towards building our amazing movie application. So, are you ready to React? Before creating a React project, you need Node.js installed on your machine. Node is a JavaScript runtime that allows you to run JavaScript code outside of a browser. This is essential because React development involves running tools and scripts on your local machine, and these tools require Node.js to function. So, head over to nodejs.org and download the LTS or long-term support version of Node.js. Those versions are super stable. Depending on your operating system, you can install it via Package Manager. That'll look something like this. You simply copy this to your clipboard and paste it to your terminal. It is super quick. Alternatively, you can download the installer and then follow the steps to install it. And when you install Node, you'll also get a handy tool called npm, short for Node Package Manager. Instead of writing everything from scratch, you can use npm to quickly add features like animations, form handling, or even full frameworks by pulling them from its massive collection of ready-to-use libraries. And it also makes it super easy to keep your tools and code up to date, ensuring everything works smoothly together. In simple terms, npm will save you time and effort by giving you access to a lot of packages to help you build your modern apps more efficiently. Now that you have Node.js installed, you'll need a place to write your React code. There are many code editors out there, and whichever one you choose, you'll be good. I prefer WebStorm, as it's a fully fledged IDE designed specifically for React development, as it offers you everything you need, from a quick project setup, error reporting, an integrated Git system, and more. And as of recently, it became completely free. And speaking of Git, while it's not mandatory to have Git installed to start learning React, it's absolutely essential for your growth as a React developer, or any kind of developer for that matter. It's a non-negotiable. So go ahead and Google, download Git, head over to their website, and install it on your device. And if you're new to Git, I've already done a Git and GitHub tutorial, which I'll link somewhere in this video. So if you want to do that too before proceeding with this React course, pause this video and then come back. But with that in mind, now that we have all the tools necessary, we are ready to create our first React.js project. There are different ways to create a React.js app, starting from Create React App, a widely used tool that's reliable but somewhat dated. Many companies still use it, but it's not the most modern option. Vite became a new norm and industry favorite, celebrated for its lightning-fast HMR, optimized builds, and speed. It's an excellent choice for quickly setting up a React app. And you can set it up manually. If you're someone who loves to spend a lot of time doing manual setups so you feel like you're a great developer, then you can do that. Just kidding. All I meant is that you can also manually set up a React app using Webpack and Babel, or directly install React and React DOM in existing projects. But why reinvent the wheel when somebody already created a rocket? Head over to Vite and notice that you can very easily create a new React application through a single command. We'll do it that way to get faster build times, improved performance, and modern tooling. So simply copy this command, open your code editor with an integrated terminal, and paste it. It'll ask you whether you want to install the package to create that React app. So say Y, yes, and it'll ask you for your project name. Let's do something like my first React app. Choose React, and choose JavaScript. Later on, we can do some TypeScript too, but for now, we'll stick with JavaScript. And there you have it. The entire project got generated in just a fraction of a second, probably before you even had a time to blink. Now, let's actually see which files and folders have been generated and for what reason. Starting from the bottom to the top, first we have the Vite config. This file allows you to customize the build process, such as adding plugins, configuring server settings, and more. It's optional for most basic projects, but can be useful if you need more advanced customization. After that, we have a readme.md file, which contains the information about the project, like how to run it, what the project does, and other documentation. And the package.json contains the metadata of our project, such as its name, scripts, and dependencies needed to run it. The dev script starts the development server, while the build script creates the production build. You can run those commands by opening up your terminal and running npm run, and then the name of the command you want to run. But before you do that, first you have to install the necessary dependencies to be able to run the application. You can do that by running npm install, or for short, npmi. Or in my case, I don't have to type anything, as WebStorm immediately asked me whether I want to run npm install. So that's exactly what I'll do. And there we go, the packages have been installed. Since WebStorm did it for me, I didn't have to worry about switching directories. But if you're doing it manually, you first have to cd change directory into whatever you named your app. So in this case, that is my first React app. And then here, you can run npm install if you haven't already. Now run npm run dev. This will run your application in about half a second on localhost 5173. You can see it live just by clicking on this URL. There we go. A simple app with a counter and a couple of icons. Don't worry, we'll delete all of this soon and start from scratch. But for now, let's move ahead and check out other files, such as the package lock.json. This file is automatically generated when you run npm install. It locks down the versions of the dependencies installed in your project, ensuring that every project installation, whether on your machine or when your colleague or boss is running your application, will install exactly the same dependencies, making sure that your app runs perfectly. Don't delete it. After that, we have an index.html, and this is the main HTML file within which your app is loaded. It has a basic structure, including the root div, which React will infuse with your entire application. Vite uses this as the entry point. And there's also the script that points to a main.jsx file, which initializes your application. We'll check it out soon. For now, let's continue up ahead to ESLint config. This is a config file used to define the rules and settings for ESLint, a popular linting tool. It helps you identify and fix problems in your code, such as coding style violations, errors, and potential bugs. After that, we have gitignore. This file tells Git which files and folders to ignore when committing your code. The most important thing to ignore are node modules. You never want to push these over to GitHub. Rather, you want everybody to just get your code, and then if they want to, they can just run npmi. And the second most important thing to ignore is the .env file, which contains your environment variables. Those need to be kept safe. Some of the other folders on the list include node modules, which contains all the installed dependencies for your project. Everything from React, Vite, and more. This folder is huge and contains even more folders within it. You never really have to get into it. It's just there for your app to work. It's completely managed by npm, and you don't have to interact with it directly. After that, we have the public folder, which contains static assets, such as images, icons, and other files that don't need to go through Vite's bundler. Files in here can be referenced directly by their path, such as /vite.svg. And finally, we have the source folder. This is where your React components and JavaScript logic go. Tailwind CSS will be applied here through the styles you import into your components. App.jsx is where the main UI of your app is defined. Whatever you write here will appear on your website. Main.jsx is the entry point of your React app, where React is rendered into the DOM. You can see that here we use plain JavaScript to get the element by ID of root and then render the entire app right within it. Since this is the entire app, here we import our main style file, index.css, where you can define the global styles of your application. After that, we have the assets folder containing media assets like images or icons, and these can be imported into your React components or used within JSX by simply importing them like this, and then using them as the source within the image component. And finally, the app CSS is the styling file specifically for the app.jsx. As you can see, we're importing it only here. You can create as many CSS files as you want and import them into different components, just to make sure that our styles are tidy and separated. Hopefully, this all makes sense. Sure, there are more files and things happening behind the scenes, but just to make sure React.js runs smoothly, you don't need to worry about those files all the time. Now, before we dive into React.js syntax and learn how to write its code, let's quickly set up something cool for the feature I'll teach you how to build today. We're going to be using AppWrite, an open source backend for your React apps. The link is in the description, so just click it and quickly create your account. We'll use AppWrite to develop a simple algorithm that tracks what users are searching for on our movie app, and then suggest the top 5 trending movies based on their search history. We'll set up our AppWrite project and connect our React app to it a bit later. For now, just creating your account is good. Let's talk about components in React. There are 2 ways in which we can define components. The traditional one is called class components. While they're not widely used anymore, they're still common in older code bases. An example of a class-based component would look something like this. Class component name extends React.component, and then there's a render method and a return statement. All of this code just to be able to return a simple H2. You might encounter these if you work on larger projects in big companies. However, for new projects, they are no longer recommended. Instead, there's a better way to create components. Components just like this one right here, where you define it by just declaring a JavaScript function. But we have a lot of unnecessary code right here. So let's actually delete this entire function and create it from scratch. You could do something like function app, or you could also use newer JavaScript syntax called arrow components. That would look something like this. Const app1 is equal to, and then you declare it like this. I actually prefer this way of creating components, so I'll just call it app and I'll just export it at the bottom. Then within here, you can say return, render an H2, and say something like functional arrow component. Now, if you head over to your browser, you should be able to see the text we are rendering, which means that the component is showing successfully. And the beauty of creating React components is that you can create as many as you would like. Something like const card component, or just card, would render a little card that looks something like this, card component. And then you can use that card within the original app component by simply wrapping it either in this interesting little component called React fragment or just a regular div. And then below the H2, you can render as many card components as you would like, just like so. In the browser, that would look something like this. And you can reuse it across your entire application. Now, just imagine if this card component actually consisted of more code, you would be able to reuse it everywhere, allowing you to write code only once and use it multiple times, eliminating repetition. And that's the power of React's component-based architecture. But of course, it'll start making much more sense as we dive deeper into some more real React apps, so I can show you how real developers use it on their day-to-day projects. But writing components is not enough. Sometimes we want to pass data from one component to another to display something specific and not create multiple similar components for every little change. And we can do that through props. In React, props, short for properties, are a way to pass data from one component to another. You typically do it from a parent component to a child component. Think of props as arguments you pass to a function. Let me quickly show you how it works in action on our current example. Let's say that each one of these cards renders a different movie title. Later on, it can also be a thumbnail, title, description, and more. But for now, let's say it's just the title. You can go into that card and then pass something known as a prop. Let's call it title and make it equal to some famous movie title. Let's go with Star Wars. The second one can be something like Avatar. And for the third one, maybe we can do something like The Lion King. Now, if we do that and save, you'll notice that no changes have been made to our app. They're all still the same, card component. Well, now we can put that prop to use by heading over to our card component and accepting that prop right into it. We have to call it title and destructure it. And then instead of rendering the card component text, we can dynamically render the title that is being passed into the card, resulting in different text for each one of these pieces of UI. And keep in mind, the prop can be anything. It can be a string, but it can also be something like a number or even a Boolean. It can even be a complex prop, which is an object. So in this example, let's pass some information about the actors, which can be an array of different objects, where we have a name of each one of these actors in a list. You can do whatever you want. And then we need to accept all of those props right here at the top and then do something with them in the UI. Pretty cool, right? Well, we're just scratching the surface of what React is capable of. So far, you're doing well. But this is far from ideal. This is looking very plain, just text on the screen. We need to give it some styles to offer a good user experience to the users. So how can we apply styles in React? Or maybe I should rephrase. Is there any kind of styling we can't use with React.js? Inline styles, CSS, Tailwind CSS, Bootstrap, Material UI, and UI, Sass, CSS in JS, CSS modules, you name it. You can choose any approach to style your React apps. So let's try a couple of these styling ways in our app. First of all, head over to index.css and remove all styles from here. This is one way of styling, where you write styles in a separate CSS files and then you import them into your component. We've imported this index.css file within our main.jsx. Let's start by applying some styles to this app. I'll start by targeting all the elements and set some styles that you typically do at the start of every single application, such as box sizing, set to border box, margin set to 0, and padding set to 0. This will reset those styles for all the elements on the screen. Next, we can target the body element and give it some padding, like 40 pixels should be enough. Oh, and I almost thought that I was writing CSS in JS, so I automatically made it a string, but that's not necessary in regular styling. We can also change the background color to something like #151515. Let's also change the font family to something like Franklin, Gothic, Medium, or if we don't have that, we can just do Arial. And finally, we need to style the H2 element by changing its color to something like #F3, F3, F3, giving it a text align of center, as well as a margin bottom of about 30 pixels, and finally a font size of 48 pixels. There we go. Now I can zoom out a bit, and we can see everything more clearly. We just applied some styles directly to HTML elements without having to manually select them right here. But if we want to be a bit more specific, then we can use class names. So let me remove this first H2, and let's remove some of these props as we're not using them anyway. And now we can give this div that's wrapping these three cards a class name equal to card-container. Notice that unlike styling HTML, you don't have to say class name all lowercase. In React, it actually has to be uppercase, N, in class name. Now you can head back over to index.css and style that class name by saying .card container, and then you can give it a display flex, flex wrap of wrap, justify content of center, as well as a max width of something like 1024 pixels. This will make it look good on all different devices. I'll also give it a margin of 0 and then auto. And naturally, if you applied an ID to this div, you would be able to style it by saying hash and then the name of the ID. Now that you know how we can use external style sheets to style our React components, let me also teach you how we can do some inline styles. We can do it on this card component by giving this div a style property and an object. And then here, you can define styles within JavaScript by saying, for example, border is 1 pixel solid, and then we can do hash 4b5362, and now each one has a border. We can give it some additional padding of maybe 20 pixels. Let's give it a margin of 10 pixels as well, a background color of hash 31363f. And notice how if you're using inline styles within JavaScript, you cannot say background dash color, it's actually using camel case, background color. Let's also give it a border radius of something like 10 pixels. And let's also give it a min height of about 100 pixels. Now, what would happen if we mixed and match both the styles from the external style sheet and internal ones? Let's add a class name right here, equal to something like a card. If you now head back over to index.css and define the .card class name and give it something like a border of 2 pixel solid red. Oh, again, I'm using string signs here where I don't need to. You can notice that the color didn't change. That means that inline styles have the preference over all the other CSS stylings. So do remember that. But it's always better to stick with one way of styling anyway. And in today's world, Tailwind CSS is the way to go. It's the preferred way of styling apps of any kind. So in this tutorial, later on, once we actually start building your movie application, you'll use the most popular and most in-demand way of styling applications through the latest version of Tailwind CSS, version 4.0, which was released exactly at the date of publishing this video. So you know that with JSM, you're always getting the latest information. Now let's quickly fix up our styles by heading over to the index CSS and removing this margin bottom from the H2. We don't need it. And now all of our cards are looking good. But remember, I already told you that it's always best to use one way of styling. So in this case, I will remove these inline styles and I'll move them over to our external style sheet. So let me copy all of this and exchange it for a class name of card. Then we can head over into our index.css and paste all of those styles here, but you'll have to change it to use lowercase letters and dashes in between. So border radius, background color, and min height. And at the end, you'll have to add a semicolon. And of course, remove all the string signs. We don't need that in native CSS. So let me quickly do that, and we're good. Everything still works as before. And with that, we are ready to dive into what I believe is the most important concept in React, called the state. State is like a React component's brain. It holds information about the components that can change over time. In this code, for example, if you have to track if someone has liked a movie or not, you'll have to use state. If you use a regular variable, something like const has liked, and set it to true, and then use it right here as a prop, has liked is equal to has liked, well, this won't work because React won't know that something has changed and it won't update the DOM accordingly. That's because React's rendering process relies on state and props to decide when and how to re-render the components. So let's create a state that allows users to interact with each card and allow them to like or dislike that movie. I'll start by heading over to our primary application and define our first state by saying const, and then you have to destructure an array like this, and then make it equal to a call to the useState hook, which you have to import from React. So right here at the top, import useState from React. Keep in mind that in React, everything that starts with the verb use typically is referred to as a hook. And React has many different hooks at your disposal to allow you to build your applications more simply and more scalably, React being one of the most important ones. And the way in which the useState works is that you first destructure the actual variable name. In this case, we can name it hasLiked, a Boolean variable in this case. And then as the second parameter to this destructured array, you can get a setter function that you can use to update that state. So in this case, set hasLiked. These are names that I just thought about on the spot, but you can follow this similar pattern. First, you give a variable name. It can be anything. And then you say set, and then use the same name. This is the common practice. For now, I said hasLiked and set hasLiked, but we're not yet done. Within the parentheses, you can also provide the default value of that state. In this case, the state is a Boolean, so I'll say that at the start, the initial state of this hasLiked variable will be set to false. And as you can see, I'm using WebStorm as my IDE, so it intelligently recognizes what this first parameter to the useState is, and it is the initial state. Of course, if a variable was something like a number, then of course you could set a 5 or 10 or any kind of value, or a string, or even a complex object. All of that is possible. Now, right within each one of our movie cards, below the title, let's implement a button that will allow us to like a movie. This button will say something like, and it'll have an on-click listener. Within here, we can define what happens when this button is clicked. We'll define a callback function within it, meaning that once this button is clicked, this function will be executed, but more specifically, whatever is right here, either within this curly braces or after the arrow function will be executed. In this case, I simply want to call the setHasLiked function, and I want to set it to true to be able to like it. Now, as you can see, if I hover over this, it's going to say unresolved function, because within the scope of this card, we haven't yet declared this setHasLiked state. It is declared within the app itself. And this is where the beauty and the complexity of React comes, deciding on where you will define which piece of state. If the state has something to do with all of these three cards, maybe something like hide all movies, and then that can be true or false, well, it would make sense to have that state right here within the app. But in this case, this hasLiked state will be different for each one of these cards. So it makes more sense to take it away from here and add it to the card. Now, if I save this, you can see a little like button appear right there, but let's also style that button further by heading over into our index.css and just styling all the buttons on the page by giving them a border of none, a font size a bit larger of about 30 pixels. Once again, I'm used to writing CSS in JS, so I'm used to this different type of syntax. And I think that just shows you that later on, once we develop this movie app, you'll learn a whole new way of writing styles, which is much better and much faster than this one here. We can also change the background color and make it transparent. Let's give it a width of about 100%, as well as a text align of right. And I know that this doesn't matter too much to teach you React, but I still want to make sure that you can visually see what this app is about and how all of these features interact with each other. And we can give it a cursor of pointer to know that this button is clickable. That'll look something like this. And now, if we click like, we cannot really see that anything changes, right? So how can we change the UI depending on the state? Well, you simply do some conditional logic. Instead of simply always saying like, we can do something like this. Open up a new dynamic block of code similar to what we did with the title. So whenever you want to render just regular text like this, then it'll always say title. But if you want to use some dynamic variable, then you put it within curly braces, and that'll make sure to make it dynamic and render the data of the variable that we're trying to render, not just the title text instead. So here we can check if hasLiked is true, and if it is, then we can say liked, else we can say like. So now for the first one, you can already see that it says liked, even though it's not that apparent because it's black. But you can see that now I can click on all of them and they will all say liked. And they'll stay that way until I reload the page. So that is a very important thing to mention, that the state is not persistent across browser reloads. As soon as you reload the browser, the component will get re-rendered and the state will return to its initial values. Now, instead of just saying liked and like, we can show some different kinds of hearts, just so it's easier to visualize it. And now think about it. How would we unlike something? That's a good question, isn't it? Currently, we're always setting the hasLiked state to true. How would we figure out if the state is already liked and then flip it like a switch? Well, you can say setHasLiked is equal to not hasLiked. So turn it around and flip a switch. Now, if you click on it again, you can see that we can like and unlike it, and it happens instantly without a browser reload. That's because when the state changes, React automatically re-renders the component to reflect the new data on the screen. In this example, initially hasLiked starts as false. Then we have the setHasLiked function, which is used to update the state. And when you click the button, it flips the switch to set the state to the opposite of its previous value. React then re-renders only that card component. And that's the beauty of React. Like when you click and change this state, it only changes this one, and it doesn't touch any other cards or elements on the screen. And then the updated hasLiked value is used to display either a red or a white heart. But if we kept the state within the app and passed it as a prop, we wouldn't be able to like or unlike each card separately. Having it here allows each card to manage its own state independently, making the component reusable and isolated. I hope this makes sense. The syntax we just used with useState, and as I told you when I introduced this hook, useState is just that, a hook. Hooks are special functions in React that let you tap into React features, like state management in this case. And there are many different types of hooks. useState for managing state, UseEffect for handling side effects like data fetching, use context for sharing data across components, and use callback for optimizing callback functions. There are plenty more as well, and we'll go over some of these in this crash course. But if you're looking to dive deeper, I've covered all of them in detail, one by one, in my React.js Pro course, complete with practical examples, when to use them, and why they're helpful. You can find a link to that in the description if you're interested. But for now, let's move over to the second most popular hook, UseEffect. UseEffect is like a special tool in React that lets you do things outside of just displaying stuff on the screen, like fetching data from a server or doing some cleanup after the component is removed from the screen. Let's say you want to log a message every time a user likes a movie. To track that, we can use the UseEffect. So let's modify the card component to implement it. Right here, below declaring the use state, I'll say UseEffect. Something like this. And then I'll import it right here from React, right next to useState. UseEffect has the following syntax. You first declare a callback function called the effect, and then within it, you put the code that you want to have executed. Something like title movie has been liked or disliked. So if I save this and open up the console in the browser, you'll see that we have quite a few console logs, 2 for each one of these movies. Why do we have so many? Well, it's because this card component got mounted 3 times, once for each one of these movies. But wait, something is not right here. Instead of 3 calls, here we can see 6 different console logs, which means that this UseEffect has been called 6 times even though we only have 3 cards. Why the duplication? Have we done something wrong? Well, not really. If you check out the React.js documentation, you'll see a question that says my effect runs twice when the component mounts. And that's normal, because we are in the development mode. When strict mode is turned on, and in development, React runs setup and cleanup 1 extra time before the actual setup. This is a stress test that verifies your effect logic has been implemented correctly. This is not a problem because once you deploy your app to production, it'll only run 3 times. But if you want to learn more properly how React really works in production, you can head over to main.jsx and then remove this strict mode wrapper. This will make sure that there's no duplication. So right now, you can see that there's 3 console logs, 1 for each one of these cards getting mounted to the UI. But now, let's say you want to track the activity of the user for some kind of an algorithm that we might want to develop within our movie app. You want to track the number of clicks to each one of these cards to be able to recommend similar movies. To do that, we'll need to create a new state. So simply say useState, and this time I won't simply start typing it, rather I'll press enter to select this template, allowing you to just type your word, like count in this case, press tab, which will automatically write setCount to provide the setter for that count variable, and then tab one more time to define the initial state of 0. Since in your React applications, it is normal to have multiple states per each component, using this quick start is always helpful. Now that we have this state, let's create an onClick handler on this card. So whenever we click on the card, we want to set count to be increased by 1. So we can say take the current count and increase it by 1. Now there's one quick thing I want to point your attention to, and that is that in more complex interfaces, it is never recommended to update the value of the state by using the state itself. Rather, what you'll often see being done is you create another callback function without the setter state call, and then you get access to the previous version of that state. And then you can do whatever you want with it, such as do prev state plus 1. In a similar way, here you can get access to the previous has liked and then toggle it on or off. But for simplicity's sake, I'll keep it right now, just count plus 1. Now let's display that state somewhere. We can display it right here next to the title. So let's say title and then maybe show the count. If you do that, you'll see Star Wars 0, Avatar 0, and so on. Maybe we can add a break tag right here to display it in a new line. There we go, that's a bit better. And now if I reload, first of all, you can only see 3 different renders. But now check this out. If you click on a movie, the number will increase. That's good. But if you keep clicking on it, even though we're not changing the liked state, this UseEffect will keep firing You can see that by this number right here. So every time I click something, we're firing a new use effect, even though we're not changing the liked state. That's not good. That's not the behavior we want. So let me show you how we can run the use effect only when something changes. To do that, you can use something known as a dependency array, which you pass as a second parameter, also often called deps. Whatever variable you pass here, React will try to recalculate and then see if it has changed. And only if it has changed, this effect will be called. So if you do this and reload, now if you continue clicking on it, you'll see that our card will actually update, the count state will change, but this use effect won't run. But as soon as you like or unlike a movie, it will immediately change its state. Pretty cool, right? And can we have multiple use effects in the same way that we can have multiple use states? Well, surely. And let me show you another most common use case of a use effect. You can just create it like this, provide a callback function, and then provide an empty dependency array. This is, in my opinion, the most common use case of a use effect. This is a use effect that runs only once on the mounting of that component, only when that component first appears. So let's add a quick console log and say card rendered. If you do that, you'll see 3 card renders. This is how UseEffect manages the side effects based on the dependencies that you provide. Now we can remove that, and instead of that, I want to teach you something else, something called conditional rendering. Technically, we already learned a bit about conditional rendering when we use this ternary operator right here. Conditional rendering allows you to show different kinds of UI on the screen depending on different criteria. For example, if you only want to render the count if it's not equal to 0, then you could say something like if count exists, then render the count, else render a null. Or in this case, you could just say count or null. So now we can see that it gets hidden, but as soon as you increase it to 1, it's shown. We just implemented conditional rendering. Another way where you conditionally rendered something were those 2 different cards. You can see, now we see one, and now you see the other. Of course, this has been just the simplest example of conditional rendering. Throughout almost every single more advanced application that we build on this channel and on JS Mastery Pro, you can see different cases in which we use conditional rendering. You'll also use it very soon when building your movie app. So with that in mind, let's delete everything that we have right here in our app, and then we'll have to create it once again from scratch. But isn't that going to take a lot of time to recreate this function for every new component? Well, thankfully, there's an extension that helps with that. No matter which code editor you use, you can head over to the plugins or extensions and then find some kind of a package that does React snippets. Install it. And once you do, you'll be able to run RAFCE. This is a shortcut to quickly create a new React arrow function component with a default export. Pretty cool, right? With that in mind, I'm so happy that you're now finally at the stage where you're ready to start developing something more serious. You now know what React is, why do we use it, how components, props, styles, states, different hooks, use effects, and so much more work. So you'll finally be able to put it to practice within this amazing app you'll build. So let's dive right in. This is a single-page application where you can view all movies from an external API with pagination. Plus, there's a search feature that lets you find any movie you're interested in. But here's the cool part. We'll simulate Netflix's top trending list. Unlike the movies pulled from the API, these rankings are based on actual user searches within the app. The more users search for a particular movie, the higher its count grows, and the more likely it is to show up as the top searched movie. We are actually building a small algorithm here. We'll do it using AppWrite. So if you haven't yet signed up, now's the time to do so. Just click the link in the description. And of course, this app is fully responsive across all devices. The main goal of this course is to teach you all the most important React.js concepts so you can implement them within your code, within this project, and all of your future projects. Alongside building the app, I'll also teach you how to deploy it to the internet so that everyone can see what you've done. See, the app you'll build today isn't just a project. It's a career asset designed to showcase everything you're capable of, making you an attractive candidate for any job. I highly recommend hosting her, so I'll put a link down in the description. I'll go with the premium plan as it allows me to host 100 websites with free SSL for HTTPS security, free email for that professional touch, and even a free domain name to give your website a good name. And because I've partnered with Hostinger, you'll get an even bigger discount. Click the special link in the description, click Claim Deal, and add to cart. Choose the period of our hosting. I'll choose 48 months to save the most. And then next to your payment method, you can enter your JavaScript Mastery coupon code, which will give you the biggest discount available. Once you've purchased, we are ready to set everything up. Let's start with Hostinger's guided setup. In this case, we'll create a new website, and we won't use WordPress. We want to have an empty HTML website, which of course will turn into a React website. As you can see, I use Hostinger for all of my domain names. So if you want to choose your domain name right now, you can do that. But if you want to do it at the end, you can click Use Temporary Domain. You can choose the server that is closest to you. And that's it. Our setup is being initialized. While our hosting is setting up, I just want to quickly let you know that there's a GitHub repo containing the entire code for this project. So if you ever get stuck, just make sure to visit the GitHub page and compare your code with the code that's on there. There's also a free complete Figma design for this project in case you want to develop it on your own. And let's not forget the extra lessons and pro courses on jsmastery.pro. With that in mind, our hosting has been set up, and at the end of the course, we'll simply change our domain to a real one and then deploy it using the file manager. With that said, let's dive straight into the code. Now, thankfully, we already have the starter code that we use to learn a bit about React, which we'll use as the basis for our movie application. The only thing you'll have to do at the end is change the folder name. But there's one thing that we don't right now have. Remember how I used to make so many typos when typing out the styles? Well, that's because this is not how we typically do styles in React. We do it using Tailwind CSS. And literally, as of the day that I'm recording this video, a brand new major version of Tailwind CSS, version 4, is now live. It brings much better performance, simplified installation, less configuration, dynamic utilities, and so much more. So in this video, alongside learning React, I'll also teach you a bit about how to use Tailwind CSS with all of its newest features. And if you'd like me to cover Tailwind CSS in more detail in a dedicated crash course, let me know down in the comments. And if many of you comment, we'll do that very soon. With that in mind, head over to the Tailwind CSS website, click Get Started, and then scroll down to the installation using Vite. The only thing we have to do is copy this command and move it over to our terminal. Now, as you can see, we're already using one terminal to run our application, so we can just create another, which we'll use to install additional packages. I'll simply paste it, npm install Tailwind CSS and add Tailwind CSS /Vite. And while it's installing, we can check out the second step, and that is to configure the Vite plugin under our configuration. So let's do just that by using Tailwind CSS under plugins under our Vite config, which is right here at the bottom. We just have to add it within our plugins array, Tailwind CSS like this. And we can import it at the top, coming from add Tailwind CSS /Vite. After that, we have to import our Tailwind CSS within our main index.css file. So let's copy this and move it over to our index.css, remove all the other code, and add it right at the top. And that's it. We can start using Tailwind within our code. Let's just copy this h1, head back over to our app.jsx, and use it right here. Class name, text-3xl, font-bold, and underline. If this syntax is looking completely new to you, don't worry, I've already done a quick crash course on how to use Tailwind CSS on the channel before, but by the time you're watching this video, maybe we have a newer one, how these different utility classes work. But in simple terms, instead of declaring all of the styles within a separate style sheet, which means that you always have to go here and then open it and then choose a class and then add it, here you just declare a class name and add these specialized utility classes. So it's not, for example, color and then red. Rather, it'll be something like text-red-500. And there's even a Tailwind CSS extension, which will tell you exactly which CSS properties that class is applying. We can also change the font a bit by heading over to our index.css. Within here, we can import different fonts. And the imports for them look something like this. It's a long string of characters that brings in different font that you can use from Google. Instead of having you manually type this out in the GitHub repo, give it a star by the way, you can find a complete detailed README where you'll have different code snippets. So head over here, find the index.css, and simply copy it and paste it in your file. Here, you can find some utility classes that'll make it easier for us to add different gradients, or just apply some styles to images, inputs, and more. And we're also importing the fonts that I talked to you about. You can see that there are some warnings right here pointing to unknown rules for Tailwind CSS directives. That is totally okay, as these are new. It is possible that our IDE didn't yet recognize them, but these are just warnings and everything should work fine. Once you apply those styles, you should be able to see that our app will now get this nice dark mode. And as I said, if you'd like a detailed start-to-finish tutorial on the latest Tailwind CSS version 4, covering how it works, its features, and the best ways to use it, let me know in the comments and I'll create a crash course for you soon. Now we can finally start with the app. Let's start from the top down, from the header, by turning this entire div into an HTML5 semantic main tag. And then below the main, we can create a new div, which is going to be self-closing, and it'll have a class name equal to pattern. You'll see what that does very soon, but for the time being, let's remove this h1 and create another div with a class name of wrapper, which will wrap our header. So within it, let's create a header tag. And within it, we can say find movies you'll enjoy without the hassle. There we go. That's looking nice. And we can turn movies into a span. And to this span, we can apply a special class name of text-gradient. There we go. So now the way this is working, and if you want to take a look at the full styles for the text gradient, you copy it and you search across all files for it, and you'll find it right here in the index.css, where you can see that we're applying a linear background from and to, and then making it clip with the text and setting it to transparent. This is more so a CSS trick rather than React, but it's very cool to know. And once again, if you'd like me to do more of these CSS tricks and show you how I came up with them, I can do a video on that too. Below this header, we'll also display a p tag of search. Later on, we'll convert this piece of text into its own component, but for now, it can remain just a p tag. And of course, let's not forget the icon. To get all of the images we'll use in this course, you can head over into the description and find a link to the Figma design. There, you'll be able to see this full design, and you'll be able to download the images. The way in which that works is you select an image. In this case, let's go with this one, and then you export it. And we can also do that for a couple of other images that we have here, such as this background. So select it and simply export it. Next, we can get the logo of our application. Then we need to show this poster not available. So let's export that too. Let's not forget about some of the icons, such as this search icon right here, which we'll want to export as an SVG, as well as a star SVG. So you'll have to click multiple times and then select it to get to it. And then you can just export as SVG. There we go. You got a quick course on Figma as well. It's very important to know how to work with designer tools as a developer to be able to put these designs into practice. So now that we've downloaded all of these assets, let's remove this vt.svg from public, open up your downloads folder, and then drag and drop all of the assets you downloaded. It should look something like this, but make sure to name them appropriately. This right here is a star, so let's just rename to star.svg. After that, we have this image right here, which is going to be hero-bg, because it's a background for the hero section. After that, we have the hero image itself, so we can say hero.png. We also have the logo.png, as well as a no movie. So you can rename all of those accordingly. And let's not forget about the search. So let's rename it to search.svg. There we go. Now we have all of the assets needed to create this project. So let's use one of these assets right within our header. Here, we can render an image that'll have a source equal to /hero.png. and we can give it an alt tag of hero banner. If you save it, you'll immediately see it right here. And if you expand your screen, you'll also see this hero background with different spotlights, as well as these vertical lines that kind of resemble a movie screen opening up. Looking great. Now, let me teach you how to create your first React component. You can do it by opening our File Explorer, heading into your app, source, and then within the source, create a new folder and call it components. Within components, create a new file and name it search.jsx. Within it, run rafce, which will quickly spin up this component. And then you can head back over to app and import it here by simply calling a self-closing search component. And if you press enter while you're trying to render it, it'll actually auto-import it from the top. But if that didn't work, you can manually do it by saying import search from /components search.jsx. Now, why cannot we see that search yet? Well, technically it's here, but it's just a dark piece of text, so it's not really showing on the dark background. Let's actually make it show by giving this div a class name equal to text-white and text-3xl. Now, how will this search work? Keep in mind, this component is only keeping track of the search term itself, not of the movies that are going to show below the search. So it's not a good idea to just create a new state here, because then what would we do with it? It is tied to this scope of the search. So what we have to do instead is create a new state within the main application, and then we'll pass it as a prop to search. Let me show you how to do that. We can use the use state snippet, and let's call it search term, set search term, and by default, we can set it to an empty string. What we can do then is pass both the state itself as well as the setter state to the search as props. You already learned how to use props, right? You simply give it a name such as search term, which can be equal to, in this case, the value of a search term coming from state, and set search term equal to set search term equal to the setter function. Oh, don't call it like this, because then it'll get called immediately as this component gets rendered. Instead, what you want to do is just pass over the function declaration. So later on, you can then recall it within the search, but it'll not get called as soon as this component gets rendered. And there's one more thing you learned right now, and that is that state fields can also be passed as props. It's not illegal. As a matter of fact, it happens super often. So just to recap, here we have two different props. And you can think of props as inputs that you pass into a component, like arguments for a function, or settings you pass to a component so it works properly. In this case, as the user searches for something, like we can say, I am Batman, right here, we can then pass that search term over into search. And then here, how do we use it? Well, you get access to all the props right here in the props object. And then here, we can maybe render it by saying props.search term. And there we go. Now it's being rendered on the screen. What you'll often see is, just so you don't have to repeat props.search term, props.set search term, props.something, you can destructure those props because it's an object. And this is not a React specific thing. It's just JavaScript. Whenever you have an object, for example, person, that has something like a name, Bruce Wayne, age 36 of location Gotham City. AI is getting really creative here. So let's say you have a person and you want to use their properties. Well, you could do person.name, person.age, and so on, right? But what you can also do is destructure name, age, and location from the person. And then you can use them just like so. Super simple, right? So in this case, what we often do with React components is the same thing. You simply destructure the search term and the set search term, which you're passing in. That way, you don't have to say props dot every time, and it'll still work. Now, there's one important thing to keep in mind, and that is that props should never be changed by the child component. They are read-only. So if you want to do something like search term is equal to I am Batman not, even though you can see it works here, you should never actually do that because it breaks the main behavior of React and actually mutates the prop in multiple spaces. So you actually don't know whether it's this value or whatever it is. And in this case, we're breaking two main rules of React. The first one being you should not mutate props. And the second one, maybe even more important one, is you should never mutate state. Yep, this is forbidden. So if you want to go something like search term is equal to new search term, this is heavily forbidden in React. You should never do this. You only mutate the state using the setter function, okay? This is important behind the scenes for React to always know what the value of these states is. Perfect. So now that we have gotten that out of the way, you know that props are read-only, and we can now implement the search using those values. I'll do it by giving this main div a class name equal to search. Within it, we don't have to render the actual search term. Rather, we'll render another div, which will contain an image of source is search.svg, and an alt tag of search. It'll also contain an input, which will be a self-closing component that'll have a type is equal to text. It'll have a placeholder equal to search through, let's say, thousands of movies. Then you can pass a value to it of search term, and more importantly, an onChange handler. That works something like this. And you'll do this very often in React. Might seem a bit confusing at first, but trust me, once you get used to it, it'll become second nature. So the way it works is that you don't manually ever change the search term. Rather, the input has a handler for a specific type of event. In this case, it's listening for an onChange event, which in this case, it's a key press. So each one of these events gets fired once you press your key. And in real world, this is often shortened just to E, short for event. And then you call the setter state and you pass over a.target.value. So now if you head back over to the app, we can reset the initial state because we don't want this to be the main search input for everybody. Rather, it should start from an empty string. You can search through thousands of movies and then you can type something. And you can see it is working. And is it actually changing the value? Well, I don't know. Let's render an h1 that'll render the actual search term. And maybe we can give it a class name of text-white. If we do that, you can see that as you type, React is dynamically changing the value of that state. And later on, we'll keep track of that value to call an API to give us movie recommendations. Great. With that in mind, we have now successfully completed a heading part of our application. A nice hero image, a background, a title, and a search input. Already in the next lesson, we'll focus on fetching movies from the best movie API on the internet. So let's do that next. In this lesson, I'll teach you how you can fetch external data, which if you're learning React for the first time, will open up a world of possibilities. That's because there are thousands of different APIs that you can call directly from your application to get super unique data to build an application about anything. If you're a fan of anime, you can do that. Fan of anti-malware, you can do that too. Art and design, authentication, blockchain, books, I mean, you name it. There is an endless list of APIs that you can use to power up your React applications. And when I was first learning React many years ago, when I learned how I can fetch this external data, it opened up the world of possibilities. For this course, I chose the Movie Database API, as we all watch movies, right? And it's free to use. So just Google for TMDB, head over to API reference, and then search for movie. We want to head over to Discover Movie. Here, you can see all the information on how you can make a request to this API, but I believe first we have to create an account to get our API key. So let's go ahead and log in. At the top right, you can create an account by clicking right here, enter a few pieces of info, and once you're in, you can head over to More, API, and this will bring us back to the page we were on. Head over to API reference, and search for Movie Discover. And this time, you'll have your own access token. So let's go ahead and copy it by selecting it from here, and let's paste it into our application. Now, in React apps, you never want to have your key right here by saying something like TMDB API key is equal to a string, because then everyone will be able to have access to it. What you want to do instead is put it under environment variables. So let's delete this and let's create a new file in the root of your folder and call it .env.local. Again, make sure that it is not outside of your main application folder, like right here. It should be where your source is, so right next to it. And then you need to start your key with the keyword vite underscore tmdb underscore API underscore key, and simply paste your key right here. Now you may need to restart your terminal for the changes to take effect and for this variable to be recognized. So head over to your first terminal, press Ctrl+C to stop it from running, and then run npm run dev one more time to spin it up on localhost 5173. Once you do that, what do you think? Which React hook do we need to use to fetch the movies? It's UseEffect. So let's import it right here at the top. Import UseEffect from React. And then below this use state, let's create it. UseEffect, which will only load at the start. How do we do that? Well, we provided an empty dependency array. Only run this once this component loads. Now, how can we actually fetch this data from the API? I mean, we have the key, but what do we do with it? Well, to know the answer to that question, you'll have to read through the docs a bit. Documentation is the most important part of learning how to code. And immediately at the top, we get the exact API endpoint that we need to call. API refers to an application programming interface. And it is simply a set of rules that allows one software application, in this case a React app, to talk to another, which is a database or server set somewhere else. In this case, we're using TMDB's API to get a list of movies. So we have to send over a request that says something like, hey, give me a list of your most popular movies. We can do that by first defining the API base URL, which will be equal to https://api.themoviedb.org/3 for version 3. We do have something after that, but we'll specifically craft that part later. For now, we just want to have the base part of the URL. After that, we can also get access to our API key by saying const API underscore key. And typically when you're naming your variables and you know they're not going to change, you can use this kind of case where you have all uppercase letters and then underscores. And here we can get the variable by saying import.meta.env.vite tmdb API key. Make sure to spell this correctly. This variable name right here needs to be the same as here. After that, we have to define the API options by saying const API options is equal to, we can define the method as get. So we want to get some movies. And then we can define the headers, which is an object where we can say accept, and you can define what kind of data do we accept in our application, and it'll be an application JSON, which means that the API will send back a JSON object, which is similar to a basic JavaScript object with some minor differences. And we have to authenticate the API by saying authorization and then say bearer and then pass the API key. This verifies who is trying to make that request. In this case, we created an account on their API, so we can do that. And we're finally ready to declare a function that allow us to fetch those movies. So let's do it above the UseEffect by calling it const fetch movies is equal to an asynchronous function that'll look something like this. Within it, when you're fetching something, typically it's a good practice to open up a try and catch block. If something fails with the API call, then you get into the catch, where you have access to the error. So then you can console.error the error, and we can also say something like error fetching movies, like this. And this way we're getting a bit more information about a specific error that happened. Now, a pretty cool thing is that we can also display that error in the browser. React makes it super simple. We can do that by declaring a new state. So let's say use state, and let's call it error message, set error message at the start equal to null, or an empty string because we don't have any message in there. But now, if we catch an error, we can set error message to a meaningful message. Something like, error fetching movies, please try again later. And now, where do we display that message? Well, wherever you want. We can create a new section right here below our search. As a matter of fact, let's put the search within the header, and then we can declare this new section about movies below the header. So it'll be section, and we can have a class name of all movies, and we can render an h2 that'll say all movies. There we go. Now what you can do is say, if there's an error message, render a p tag with something like text-red 500, and then display that error message. We'll actually explore that in practice very soon. But for now, we have to keep trying to call the API. We're not even successfully calling it yet. So now let's move into the try block where we can try to call it. And first things first, we need to define the exact endpoint that we're trying to call. And the endpoint will be equal to a template string where we put together the API base URL, and then we go to /discover /movie sort by equal to popularity .desc for descending. So this will make sure to fetch all the movies. Once we have the endpoint, we can try to call it by saying const response is equal to await fetch, to which we pass the endpoint and API options. Now, see this fetch over here? This is a built-in JavaScript function that allows you to make HTTP requests, like get or post to different APIs or servers. It's like sending a letter to a service and getting a reply. In React, fetch is often used to get the data from APIs for displaying it on the website. So how do we actually put this fetch movies to practice? Because right now it is completely unused. What do you think? Well, we can simply call it as soon as the app loads. So if I call it within the UseEffect, like this, what do you think? Will it work? Fetch movies, no errors, right? Which is a good thing. Maybe we can put an alert and just alert the response. Yeah, that works. We get some kind of an object back. That's great. But what would happen if something went wrong? For example, if an error happened here. Like we can throw a new error, say failed to fetch movies, just to simulate a wrong call. If I do this, you can immediately see error fetching movies, please try again, error message happening at the bottom. No reload, no nothing, it's just immediately there. But thankfully, we don't get it if we don't manually throw it, which means that we do get back some data. So let's actually parse this response into a JSON object by saying if not response.ok, well, in that case, we might want to throw some kind of an error saying failed to fetch movies. But if the response is okay, we can get data by saying const data is equal to await response.json. And finally, we can console log that data to see what do we have in there. If I reload the application and head over to inspect and then open up our console, you can see that we get back only one object. Doesn't seem like a lot, does it? But if I expand it, we only get back the first page, which has 20 movies in it. I'll need to expand it to view it more properly. There we go. These are only 20 movies. And for each one of these movies, take a look at how much data do we get. We get an image of that movie, the ID, the original language, title, overview, popularity, poster path, release date, title, video, vote average, vote count, and more. And we get this for every single movie. And this is just the first page. But take a look. We have 48,000 total pages, which is almost 1 million movies. Pretty crazy, isn't it? And now we can infuse our React application with all that data and show it to the user. So let's do just that. I'll say if data.response is equal to false, then I'll set the error message equal to data.error or fail to fetch movies. Sometimes something wrong can happen. We have to handle that error. And in this case, it will also be a good time to create a state field, like an empty box, inside of which we can place all of these movies that we fetched. So let's create it right here at the top. I'll call it use state, and I'll call it movie list, or we can simply call it movies. It's up to you. Set movie list at the start equal to an empty array. Another state we'll have to have, and we often have those in React applications, is the loading state. So we can call it isLoading, set isLoading at the start set to false. Because when you're fetching something from an API, it takes time, maybe a second or two. So while that data is loading, you want to make sure to show some kind of a loader to the user. So we're still here in the case if it fails. If it fails, we simply want to set the movie list to be equal to an empty array, and we want to return, meaning exit out of the function. But if it succeeds, then we are ready to set movie list to be equal to data.results, or an empty array. So this will actually finally populate the movie list with real movies. Another thing we have to do is turn on the loading. So before anything happens, right at the start, we can set isLoading to true to start the countdown. And we can also set error message to nothing because it doesn't exist yet. And then there's another clause to the try and catch, and that is the finally clause. So finally, no matter what happens, whether we succeed or fail, we want to stop the loading. Why? Because if we succeed, we'll show the movies. If we fail, we'll show the error message. No need to show the loading state. With that in mind, now that we have this function that fetches all the movies, called fetch movies, we're calling it at the start, we're finally ready to use the data that the fetch movies populated into our movie list state. So let's head down a bit, and right below all movies, let me show you a bit more complex conditional rendering. We won't show this error message always. Rather, first, we'll check if we're currently loading. So if is loading, then open up a ternary operator and show a p tag of loading ... Maybe we can also give it a class name equal to text-white. Else, if we're not loading, check if an error message exists. And if an error message exists, then render another p tag that'll have a class name equal to text-red-500, and it'll render the dynamic error message coming from the state. And if we're neither loading nor showing the error message, then we want to show an unordered list, a UL element, inside of which we're going to map over the movie list by saying movie list.map. By the way, this is something you often do in React. Whenever you have some kind of an array of items you want to map over, you simply call that array, call the .map method on it, get the individual element like a movie from it, and then automatically render something. Now, make sure not to open up a function block here by putting the curly braces. Instead, put parentheses. Because if you put curly braces, which is totally okay, but then you would also have to say return here. But if you use just immediate return by using parentheses, then you don't have to say return, making your code a bit cleaner. For each one of these movies, return a p tag that'll render a movie title. And now if I save this, it seems that nothing happened. But if I apply a class name to this p tag equal to text-white, check this out. We get 20 of the most popular movies at this exact point in time. For you, this list will be different from me because some other movies are trending. And that's the beauty of calling APIs. You don't have to worry about the data. Somebody else is doing that for you. Now, another important concept in React is a concept of a key. Whenever you're mapping over a list of elements, you want to make sure to provide a key to each one of these elements you're mapping over. That key has to be unique, something like an ID, so we can simply pass the ID belonging to this movie. This is needed especially if you're deleting some of these elements from the list, because React then might confuse the two elements together and be not sure what to render. But if you give each one an ID, then it'll always know which one it is, and you'll have no unexpected behavior in your browser. Great. With that in mind, let's check how these movies are loading. Like if I reload right now, oh, they're already stored in memory, so it's super quick. But for a brief second, you should be able to see loading right here. For now, we can simulate it by heading over to our state and turning the isLoading initially to be set to true. And then under fetch movies, if you head over to the bottom, in the finally clause, you can also set it to true. And now you can see loading. But this is not looking that interesting, is it? It would be better to have some kind of a real spinner that looks like this. There are many different spinners online. People offer them for free. They work in different light or dark modes, and you can simply copy the code. I'll put the link to this website in the description so you can find your spinner of choice and just copy it to clipboard. Then we'll create a new component by heading over to Source, Components, and let's call it spinner.jsx, run RAFCE, and instead of this div right here, simply paste the code that you just copied. It'll be a bit of a longer code because it's an SVG, but that's okay. And at the end of this class name, instead of fill blue 600, change it to fill indigo 600. I think this color pops a bit more on our background, or any color of your choice. Now, if you head back over to our app.jsx, instead of simply returning a loading text, if it's loading, we can return a new component, which we can import from the components folder, and it'll look something like this. Much better, right? Now we can bring this back to false, and same thing right here at the top initially. Great. Also, let's quickly give this h2 a class name of margin top of something like 20 pixels. And we can do that within square brackets like this. There we go. I think maybe even 40 will do. Perfect. With that in mind, now we have a fully responsive, great looking list of movie names or movie titles, but not movie cards. One thing I love the most about all of these APIs is when they're visual. People are visual beings, and seeing something that looks like this with a lot of movie covers, ratings, and more is much better than just seeing the titles themselves. And we'll do that next. But it's not that hard, is it? Once you understand something at its core, it won't feel tricky the next time. And that's why before, in the crash course, I went into detail about how UseEffect works, and I showed you how to implement it. So this time, you fully understand how it does, and you'll be able to replicate it in all of your apps in the future. But that's just one hook. And there are many more in React 19. Like use action state is one of these hooks. Use optimistic, use form status, and I also think there's a use transition. Yep, that's here too. And each one of them comes with its own quirks. I'll cover each one of these in depth along with their specific use cases in my upcoming pro course. So if you want to go beyond what most people learn, be sure to check it out. The link is in the description. There's either going to be a waitlist or, if you're lucky, the course will already be there. With that in mind, let's turn this into this. Let's develop a movie card component. We can do that by creating a new component in the components folder and call it movie card.jsx. Run RAFCE and then import it directly within your app.jsx. Specifically, we want to render each one of these cards instead of a movie title. So remove this p tag, or rather just copy it, and instead of it, render a movie card, which you can automatically import from components, pass in a key equal to movie.id, and also pass in a prop of movie equal to movie. Remember how props work? We want to pass all of this information from here about each one of these movies to the movie card. This will allow you to destructure that movie right here, and then within this div, we can render the same thing we previously had, which is a p tag that renders the movie title. So if you go back, nothing should change. Everything is still the same, but now we have this new component within which we can work to make it fully reusable and not keep everything in our app, which would clutter the view. Now we can put things that specifically belong to the movie card within it. Now, I already told you how we can destructure the props, so we don't have to say props.movie.something. But this time, we'll have to say movie.something many times. Movie.id, movie.postercard, movie.title, and so on. So what we can do is destructure more properties from the movie itself. You can do that by saying colon, and then saying which properties you want to take out, such as the title And now you can simply say title. We don't need a key in this case because we already have it here where we're mapping over it. But now you can see the same thing, but we don't have to repeat ourselves. We'll also use a couple of other things belonging to a movie, such as a vote_average for the rating, poster_path, release_date, and original_language. You can also put this in a new line, so it's a bit easier to see what's happening. Great. Now let's create this movie card by giving this div a class name equal to movie-card. Already, this will apply some styles that I prepared within the index.css. So if you head over into the index.css and search for the movie card, you should be able to see that this will apply a dark background, a bit of padding, rounded corners, and some shadows. Exactly what we get over here. Instead of a p tag right here, let's render an image, and this image will render the poster path. So let's say source is equal to, if a poster path exists, then we want to render https://image.tmdb.org/t/w500/poster_path. This is the full path to that image. And if a poster path doesn't exist, we can render /nomovie.png, which will render our dummy image. So with that in mind, you can see that now we get access to the images belonging to all of these great movies. Looking great even on mobile devices. As you can see, on mobile, we can only see one per row, but as you expand it, check this out, you can see 2, 3, 4, and it is just looking great. Perfect. We can also give an alt tag to this image, and it'll be equal to the movie title. Below the image, we can render a div with a class name equal to margin top of 4, and within it, we can render an h3 that'll simply render the movie title. Perfect. Then we can go below that h3, render a div that'll have a class name of content, and within it, we can render another div that'll have a class name of rating, and within it, render an image with a source equal to star.svg with an alt tag of star icon. And now you can see a little star right here belonging to each one of these movies. Next to the image, we can also render a p tag, which will check if vote average exists, and if it does, we want to render the vote average .toFixed1. And if it doesn't, we can just say something like NA, doesn't exist. So now this will round down the number to the first fraction digit, 7.7, 6.5, and so on. Looking great. We can head below this div right here and render a span. This span can render one of these special dot characters just to create some separation. I think if you just Google for dot symbol copy, you should be able to find it somewhere. There we go, this is the one. So you can copy it and then paste it here. I like using those to create some separation. Below it, we can render a p tag with a class name of lang, as in language. And here we can render the original language. In this case, it says EN, as in English. After that, we can render another one of these spans. So let's actually put it below. And then below that span, we can create another p tag, which will have a class name equal to year. And there we can check if a release date exists. Then we'll want to render release date dot split based on the dash and only take the first part of it. So we only want to get the year, else we'll say NA. So now we get 2024, 2024, 2025. Great, we have the newest movies right here. But even if you're watching this in 2026 or 7 or 8, let me know in the comments down below. The video should still be relevant. But if that is the case, it's highly likely that I have more relevant content on jsmastery.pro. So head over there and watch it there. But with that in mind, believe it or not, this is it for a movie card. This is called a presentational component. It doesn't handle any logic. It is just accepting some props we pass into it and rendering them. So now if I full screen this, you'll be able to see how it looks like. as we scroll through those movies, and let me zoom in just a tiny bit, take a look at how great this looks. We're getting full resolution images back, and we're rendering them right on the screen. And if I render, most likely they'll be cached already, so you won't even be able to see the loading screen. But if you have a slower connection, you'll be able to see that loader. Now, in the next lesson, let's power up our use of this API by implementing search. That way, you'll actually be able to type in a movie name you want to find, and the top matches will pop up right here. To implement search, we'll reuse the same fetch movies function that we've created before, but we'll have to tweak it just a tiny bit. We'll have to track the changes in the search term state, and whenever it changes, we'll have to recall the fetch movies function with a different API call that's used to fetch movies. No longer will it be discover movie, now it'll be a search movie, and we'll also have to pass a mandatory search query string. So let me show you how to do that. First, I'll make this fetch movies function accept a new param called query, at the start equal to an empty string. And then we can pass over our search query from the state or search term into the fetch movies function, which will then be populated as a query right here. Oh, and let's not forget, we want to recall the fetch movies with the updated search term whenever the search term changes. And you already know how to do that. You just add the dependency into the dependency array of the UseEffect, search term. So whenever it changes, this function will be recalled and fetch movies will be called with the updated query. So we can now modify the endpoint by saying if a query exists, in that case, we can have one call, else we can have another. So if a query doesn't exist, we just want to use the same one we used so far. But if a query does exist, we want to modify it just a tiny bit. First, get the API base URL, but this time it'll be /search/movie to which you want to pass the query. But we want to make sure that this query is optimized to be displayed in the URL or to be called as an API call. So instead of just passing it as a string, we can say query is equal to encode URI component. This function encodes a URI by replacing each instance of certain character by a couple of escape characters representing the UTF-8 encoding. This will make sure that our search term, no matter which weird kind of characters it has, still gets processed properly. And to it, we can pass the query. And everything is still the same. We're still getting back the response and then setting up the movies to our state. The only thing that was different was passing the right query to the right endpoint. So if I reload and I start searching for something like, let's say, the Batman, you can see that the search is fully functional. And of course, this is working even better on desktop, as you'll be able to see more movies at the same time, maybe Dark Knight. Yep, this is working great. What is your favorite movie? Let's go with Godfather. It's one of the classics, or maybe Avatar. Or maybe you like anime, something like Attack on Titan. That should be there too. There we go. While typing these movies, I'm sure that to at least one of you, I've chosen your favorite movie. But yeah, with that in mind, this search is now fully functional and it works. And if we type something that doesn't exist, you can see that we get nothing here. And if we type something random, you can see that even if a poster doesn't exist, everything still works and it doesn't break because we put that dummy poster not available image. But we're not done yet. In the next lesson, I'll teach you how to optimize that search. Right now, as soon as you type a single letter, a request is made. Let me show you. I'll type the letter A, and immediately you get back the movies that match the letter A. But let's be honest, that's not really what you wanted. That's not the expected user behavior. You don't want to get the movies for the letter A, you want to continue typing. So you go ahead and type the letter V. You are still not done. You're about to type Avengers, but hey, now you got the AV, the hunt, and so on. Not only is this not good for you, the user, but it is terrible for our server because things can very quickly get overwhelming. Every time that you type a letter, one character, one request. And this can easily lead to an excessive number of API calls, killing your daily usage and increasing your bills. This causes two problems. The number one is API overload, which might exhaust the server resources. And the second one is rate limiting. The API might have the too many requests rule, which could automatically break the application or lead to throttling. So let me teach you the solution. It's called input debouncing. As you can see, we can enter a couple of characters and they're being sent only once. So one more time, 1, 2, 3, 4, one request, 5, 6, 7, 8, one request, while in the regular way, we send one API for each number. Debouncing is commonly used to address the issue that we just experienced. This technique helps us delay the request until the user has stopped typing for a predefined amount of time, reducing the frequency of API calls. So let me teach you how to implement debouncing using a pre-made UseDebounce hook from the React Use package. This hook will help us manage the delay for us. As you can see, UseDebounce debounces a function, and we can simply get access to that code by installing a package. And this is actually a great way for me to show you how you don't have to build everything inside of your React apps. Just head over to npm, search for what you're looking for, and then simply install it by using the npm I command. We installed Tailwind CSS in a similar way. And now we can simply use it. Let me show you how. Right at the top, we can import UseDebounce coming from React Use. And then we can create a new useState field. This time, we'll call it a debounced search term and set debounce search term at the start equal to an empty string. Then we'll simply call the UseDebounce hook, pass a callback function to it, and call the set debounce search term with the search term that we have, but we can pass a specific number of milliseconds for how long it should wait before actually changing that value in the state. This is how this weird little hook works. So instead of passing the real search term, which gets updated on every single keystroke, we can now pass over a debounced search term into this UseEffect dependency array and into the fetch movies function. The UseDebounce hook will take care of the rest. Basically, what it does is it debounces the search term to prevent making too many requests by waiting for the user to stop typing for 500 milliseconds, which is half a second. So check this out. If I want to type something like Avengers, I can now continue typing and it'll not make a single request until I stop typing for half a second. So if I stop, it made a request, but it looks like I have a typo. So if I fix it, we're good. Of course, using this hook is amazing, and I would even recommend installing additional packages like this to help your workflow. But sometimes it's good to understand how these hooks work behind the scenes. So learning how to implement one from scratch by yourself, not by using an external package, is excellent practice to learn how React works behind the scenes. Does this make sense? Many creators won't even dive into this at a beginner level, but I believe it's important to understand it right from the start. It's not just about building something, but about building something that truly adds value. So next time you're in an interview, don't just say, "Hey, I implemented search functionality." Instead, explain that you built an optimized search solution that improves performance by debouncing the input field. That level of detail will set you apart. And yeah, I hate to repeat myself here, but I've been diving into similar concepts and many more advanced patterns that boost performance optimizations, caching, SEO, and more in the upcoming React.js Pro course. Because it's all about that real-world production-level practices. No fluff. So if you haven't already, you know the deal, join the waitlist, and I'll see you there. But with that in mind, we are now ready to move to a part of this app that I'm super excited about. And that is the trending section. You know that famous Netflix trending section? Well, I'll teach you how to do just that. So let's do it in the next lesson. To create a feature that displays trending movies, it's essential to understand exactly what users are searching for. The more frequently a specific search is performed by multiple users, the higher its trending status becomes. This requires tracking and analyzing search patterns over time. For example, if many users search for Squid Game, well, Squid Game will become trending. To track and analyze these searches, we need a place to store the data permanently. If you think about it, state is a way of storing data, but it's not a permanent store of data. Something called a database is. We use databases to store information and then retrieve it when we need it. And traditionally, implementing this would mean building a full stack application, meaning that you would have to develop a server, set up a database, connect them, host everything, and only then integrate it into your React project. While this approach works, it can be a lot of effort and requires diving into backend development, which is a whole different area of expertise. An easier way to get backend functionality without starting from scratch is using a backend as a service platform. These services like Firebase, Supabase, and Apprite take care of the backend setup for you, providing you easy-to-use APIs that let you store data, manage auth, and more without needing in-depth backend knowledge. In this course, we'll use Apprite because it's simple, open source, and free to use. Plus, it saves us from diving headfirst into backend work when we really just want to focus on making our React app awesome. So, click the link in the description and then create a new account. You'll be redirected to your dashboard, and as you can see, I already have many Apprite projects, so let me create another. Call it something starting with JSM, maybe a movie app. You'll have to choose a different name. And choose a server. Once you do that, you'll be redirected to your project's dashboard. I'll zoom it in a bit, and you can copy its ID. We can head back into our .env.local and add it right here below by saying vite apprite project ID and make it equal to the ID that we just copied. Next, we'll have to set up a platform for our project. In this case, we'll use web. You can enter the name, such as React, and a host name can be set to asterisk, meaning everything, to make sure that we can call it from anywhere. Click Next, and then you'll have to install Apprite. So let's copy the installation command, head back into your terminal, and paste it there. Then click Next, and Next one more time, and go back to the dashboard. Then you can head over to Databases and create a new database. You can call it something like Movies and create. Make sure to copy its ID and add it to your .env.local under the name of vite_apprite_database_ID. And we can also create a new collection within that database. Let's call it metrics. Click create, copy its ID, and let's also add it right here as vite apprite collection ID. Perfect. Now let's create different attributes for each one of these metrics. We'll need the actual search term, which will be a string. So let's call it search term. Enter the size, something like 1000 characters, and it'll be required. After that, we can have a count of how many times have users searched for that search term. So let's create a new integer, call it count, and enter the default value of 1. Doesn't have to be required. After that, we can also save a URL called poster_URL and make it required so that we can immediately save the URL of the poster that users are searching for in our database, as well as its movie ID. So let's do another integer, and it'll be called movie_ID, and it'll be required. Perfect. So make sure that your attributes are called exactly like this, required, and have the same types. If you call them differently, you'll have to change how we use them within the code. Now, head over to Settings, and then to the permissions. Click plus, any, and give all permissions. This is just to make sure we can make calls to our database without any worries. And click Update. With that in mind, let's head back over to our code, and within the source, create a new file called apprite.js. And within here, we'll do all of the setup. But before that, let's simply try to console log our envs, just so we're sure we can access them. We can do that by saying const database_id is equal to import.meta.env.vite_apprite_database_id. And we can duplicate that and just rename it to collection ID and say collection ID right here at the end as well. Oh, and we'll also need the AppWrite project ID. So let's duplicate it one more time. And let's just rename it to project ID is equal to import AppWrite project ID. Perfect. Now let's console log them. That's going to be project ID, database ID, and collection ID. But for this file to be executed, we actually have to call some kind of a function. So what do you say that we immediately create a function here that will update the search count? It'll look like this: export const update search count, which will be equal to an asynchronous function. And for the time being, the only thing it'll do is it'll console log those environment variables just to make sure we have access to them. So now we can go back to the app.jsx, and right at the bottom, after we set the movie list, we can call the update search count like this, and make sure to import it at the top coming from app.js. If you do this, go back to your browser and reload the page, and then open up the console. You should be able to see 3 different IDs. In case you can't see them, sometimes it's possible that Vite will not automatically restart the server for you. So you can do that yourself manually by pressing Ctrl+C and then rerunning it by running npm run dev. But if you have those keys here, that's good and means we can proceed. So let's implement this function that'll track the searches made by different users. This function will take in 2 parameters. The first one will be the search term that the user has searched for. And the second one will be the movie associated with that search term. So all of the information about the first movie that pops up once the search term is entered. The function has to do the following things. Number 1 is to use AppWrite SDK or API to check if a document already exists for the search term. So to check if a document or search term already exists in the database. Then, if it does, that means that the search term has been searched before. So in this case, simply update the count. But if a no document is found, then create a new document with a search term and count, and set the count as 1. So now, how would we implement it in practice? Well, first things first, we have to get access to AppWrite's functionalities by defining a new AppWrite client by saying const client is equal to new client coming from AppWrite. So you can import it at the top. And then on it, you can call the .set endpoint and set it to https://cloud.appwrite.io/v1. Similar to how we set our movie API. Here, we're pointing to AppWrite servers. And you also have to set your project pointing to the current project ID. Similar how in the movies API, we had to have our own safe token. Once we have the client, we can define which functionality we want to use from AppWrite, and that is the database functionality. So we can say const database is equal to new databases coming from AppWrite, and to it, we pass our current AppWrite client. Great. So now let's use the AppWrite SDK to check if a search term already exists in the database. We can do that by opening up a try and catch block. In the catch, we can simply console log the error if there is one. But in the try, I'll say const result is equal to await database dot list documents. In which database do we want to list the documents? It's going to be the database with our current database ID. So you can pass it as the first parameter. From which collection? Well, it's going to be the collection ID, this one. And then as the third parameter, we can pass an array. And within that array, we can say query, which has to be imported from AppWrite, dot equal search term has to be equal to the search term. So we're matching what we have in the database with what our users are searching for. After that, if result.documents.length is greater than 0, so if the document exists, then we want to get that document by saying const doc is equal to result.documents0, and then we want to update the count. We can do that by saying await database dot update document. Which document we want to update? Well, the document under this database ID, this collection ID, and this document ID. And then what do we want to do to it? Well, we want to set the count to be equal to current doc.count plus 1. That's it. And then else, if it doesn't yet exist, that's going to be the step 3 already. So step 2 is if it does exist, update the count. That's this if statement. And this is the step 3. If it doesn't, then create a new document with the search term and count as 1. So instead of calling databases update, we'll say await database dot create document under this specific database for this specific collection with this specific ID. We can get it ID dot unique like this, but make sure to import this ID unique from AppWrite right here at the top. That will allow you to simply create a random ID for this document we're creating. And then you can pass an object containing different pieces of data that you want to pass to it, such as the search term, the count set to 1, and what other attributes do we have? Do you remember? I think it was the movie ID, so we can set that to be equal to movie.id, but make sure to have the underscore right here. And I think we had poster underscore URL, which we can set to be equal to template string https:// image.tmdb.org/t/p w500 and then movie.poster_path. Perfect. I believe now we have everything we need to be able to save our searches. So now we can head back over to our app.jsx. And by the way, to quickly switch files, I don't always go here and then search for the file manually. I use the Command or Control P on my keyboard and then start typing where I want to go. So app.jsx, arrow down, and then enter, and we're immediately there. So now, whenever a user performs a search, which is right here below, we want to update the search count. We can do it something like this. If there is a query, and if data.results.length is greater than 0, so means if a movie exists for that query, then we want to await update search count, make sure to import it at the top, to which you provide the query and the information about that movie. So that's data results 0. So it knows what to save. And that's it. Let's perform a search, and then I'll show you how this record appears in the AppWrite collection. Let's go with something popular like Venom. Let's go Venom right here. Okay, we search for it. This is the one that shows at the top. And now if you head back over to AppWrite databases, movies, collections, you'll be able to see 2 different documents. The first one has the data of V. Looks like I wasn't fast enough, so maybe we can increase the debounce value. But the second one should be good. Check this out. Data, Venom. So it has been successfully saved with a count of 1. Now, let's keep searching. Maybe this time I'll go with something like Wicked. Okay, and now let's also simulate another user going to Venom. So we search for it 2 times. So now if I head back and reload, we see 3 different documents. One is for Venom, and it has a count of 2, which means that this worked successfully. And we also stored its ID as well as its poster URL. And then the new one is just Wicked right here with a count of 1. I think you understand how this is working. So the more people search for something, the higher the count will be, and then we can show it in our trending list. And with that, you saw how simple it was to set up AppWrite to use its database functionalities. So now let's head back over to our app and let's fetch that data from the database so we can display it right here at the top. Now that everything is in place and we know what our users are searching for, we are ready to show this trending list of movies. But before we focus on the UI, we need to create another AppWrite function to be able to fetch the top movies from the database. So create it right below by saying export const get trending movies is equal to an async function that looks something like this. This time, we don't need any parameters, as we'll simply fetch it from the database. Let's open up a try and catch block, as always. In case something goes wrong, we can console log the error. But in the try, we can try to fetch those movies by saying const result is equal to await database dot list documents, and list them from the database with the database ID and the collection ID that we pass. But then we can provide an array to specify which movies we want to get. Specifically, we want to limit the query to only show 5 movies. We don't need any more. And we can do it in a descending order. So query.order descending, sorted by count. So the ones that have the highest count will appear at the start. And finally, simply return result.documents. This is it. This is enough for us to fetch those movies on the homepage. So let's head back over to app.jsx and let's create yet another state for our movies. This time we'll create trending movies. So another state, trending movies, set trending movies at the start equal to an empty array, as always. And I know that this app is not super simple, not something that you might consider your first app. It has many states, many different hooks, functions, API calls, and even databases. But I really wanted you to have a real experience of what building with React is really all about. This is how real apps look like, not just a single use state and then some UI. Typically, it does get messy, like with what we have right now. So with that in mind, let's create another function right below fetch movies, and let's call it const load trending movies, which will be equal to an asynchronous function where we have a try and catch block. In the catch, we get the error, and we can say something like error fetching trending movies, and we can also set the error message to error fetching trending movies, so we know if something goes wrong. Oh, but no, this wouldn't be good, because currently we're checking if an error message exists, and if it does, we're not even showing a regular movie list. So if the trending movies are not working, this would actually break our entire application's functionality, and we don't want that. So you see, you gotta be careful with that conditional rendering. So in this case, I will not set this error message here. I will simply console log it. And in the try, we can simply fetch the trending movies by saying const movies is equal to await get trending movies. Make sure to import it at the top, coming from appright.js. And then once you have it there, we can simply say set trending movies to be equal to movies. Or not equal, you pass it into the setter function. So what do we do with those movies? Well, first of all, we have to actually use this function, because right now it is fully unused. So what do you think? What would be the best place to call this load trending movies? Maybe within a UseEffect, right? Here we're fetching movies. Might make sense to load the trending movies too, but not really. Because if you do this, then trending movies will be refetched every single time that our current user searches for something. And that'll cause too many necessary API calls. So instead, we'll leave this UseEffect as it is with its own dependency array. And check this out, we'll create yet another UseEffect. This time with an empty dependency array, which means that it'll only get called at the start. Finally, now that we've done that, we can head over above our current all movies section, remove this margin top from the H2, because now we'll implement a whole another section right below the header. I'll check if trending movies.length is greater than 0, meaning if trending movies exist, then render another section. That'll have a class name equal to trending. And within it, render an H2, where we can say something like trending movies. There we go. Here it is. And then below it, we can render a UL, an unordered list. And within it, we can map over the trending movies by saying trending movies dot map where we get each individual movie, and we can also get its index. And then for each movie, we want to immediately return an li, which is a list item. And don't forget, since we're mapping over it, we have to give it a key equal to movie.$ID, because now it's coming from the database, and typically databases start their IDs with something like $ or underscore. And there we can render a p tag and render the index plus 1, because indices start at 0, but this time we want to start from 1. And you can see that now we get 1, 2, 3, 4. Perfect. But let's actually show something next to those numbers, like an image with a source equal to movie.poster_URL with an alt tag of something like movie.title. If you save this, you should be able to see different posters appear right here. And it looks like I searched for Avengers a few more times than what I did for Venom. So if a couple more users search for Venom, let's see what happens. That was 1. Maybe I can delete it and then search for another. And now if I reload the page for the trending movies to be reinitialized, you can see that Venom now gets the first place. Let's try to search for some other popular movies nowadays. Maybe The Gladiator. So if I do this and search for The Gladiator, we see it, and I'll search for it a couple more times just to see whether our trending movies will properly recognize it. I'll reload the page, and there we go. Now The Gladiator is on the 3rd place. And with that in mind, believe it or not, you've done it. I'll close this file and expand my browser fully. And there you have it, your own movie application with a trending movies functionality. Isn't this cool? Not only can you search for different movies, but you can also know what is popular within your app based on other people's searches. That was awesome to learn and implement, right? As an extra task for you at the end of this video, maybe you can implement loading and error states for the trending movies. Remember how I said that if we change the error message here, that the movies would not load? Well, that's because we need a whole another loading and error state for the trending movies. So right now we have the is loading as well as the error message for all of the movies. And then we have the search term. Maybe we can sort it a bit better. And a movie list and the trending movie list. But the better way to sort it would be to have the movie list right here, and then the error message, and then the is loading. But then for the trending movies, you can also implement the error message and is loading and properly render it on the screen depending on if something fails or the time it takes to load. Pretty cool little exercise, right? In any case, I hope you gained a lot from this video. And for some of you, things might not have yet fully clicked, but that's totally fine. Feel free to rewatch it and try it on your own without watching the video. There's no secret formula to becoming a great developer. I started the same way. When I learned something new and it didn't quite make sense, I'd retry it on my own and practice it over and over and over again. You can do the same and you'll start to see the results. Since we're very close to the end of this video, I just want to say that if you enjoyed my teaching style, and maybe you did since you're at the end, make sure to sign up to the waitlist or check out the upcoming React.js Pro course to dive deeper. YouTube is great, but on jsmastery.pro, I provide you with a bit more structure and exact path on what you have to learn next after you master JavaScript, React, Next.js, and so on. No matter where you're at in your journey, I'll provide you with the next step to become job ready. But on that note, there is one thing that will surely make you more job ready, and it's within this course, and that is the deployment of this great application. Not only have I taught you how to build it, but now you want to share it with others, right? It's a pretty cool app and you want to have it online and you want to show it to your friends, colleagues, or maybe even put it on your portfolio. To do that, you can head back over to your code, stop your terminal from running, and then run npm run build. This will generate an optimized production build of your application in about 800 milliseconds. Damn, these builders are getting fast. If you open up your file explorer, you'll notice that now there's an additional folder here called dist, as in distro or distribution. So just click it and then open it in your Finder or File Explorer. it should look something like this. Once you do that, head back over to your Hostinger dashboard and head over to the project we created. Now might be the perfect time to use that domain that you chose. You can either do something like, JSM movie app, which is a bit specific. So you would get this domain specifically for this app, which is totally okay. You can see it's $0 for the first year. But what I would recommend is getting the domain name for your portfolio instead. So something like your first and last name, .dev or .com, like jsmadrian.dev, or .com is even better if it's available. With that domain, you would have one single place for your portfolio and you would be able to put many projects on there. So in this case, I can go with something like adrianjsmastery.com, click next, and once the domain is connected, you can head over to your project's dashboard, go to File Manager, head over into public HTML, delete the default PHP file, because here we're going to upload your website. So delete it, open up your Finder, go inside of it, and then simply copy everything and move it over to this public HTML. This contains the index.html file as well as all of the assets needed to run your React app. Once you do that, go back to your Hostinger dashboard. Make sure that the SSL certificate for the domain has been installed. Typically, it takes a couple of minutes from once you select your domain name. There we go, it's done. And then click on it right here. And check this out. We are now live under your specific domain name. You can find all of the popular movies as well as see what other people are searching for, or you can search for something yourself. Do we have any movies about JavaScript? Who knows? Well, not really. What about React? Well, this is good enough, I guess. Keanu running away from some kind of a chain reaction? That reminds me of working with Redux, which is kind of an advanced React state management library that was used back in the day. But in today's world, you don't have to worry about that because there's simpler and more advanced technologies to help you manage your state and bring your React game to the next level. For example, the best next way forward after learning React is to dive into Next.js, as Next.js is a framework that is built on top of React that allows you to turn your front-end React apps into full-stack apps with optimized performance. So if you're not sure what to do next, well, Next.js is the way to go. With that in mind, once again, thank you so much for watching. I hope you learned a lot. Let me know what you want to see in the next one. I'll see you inside jsmastery.pro and have a wonderful day.